What's going on, guys? In this video we are going to see how to show whether these three functions are linearly dependent in this interval negative infinity to infinity. Okay, to show linearly independent, what we have to do is we have to first create an equation like constant multiplication of all of these three should be equal to 0. Then only this is linearly dependent. If we cannot prove that one, then it means this is linearly independent. Now let's go ahead and create the equation. First I create some like constants. First c1 multiplied by 2t minus 1, that's our first function, and then plus c2, another constant, multiply the second term, that's t plus 5, and then plus c3 multiplies the third one, 4t minus 7, and all of these should be equal to 0. And this c1, c2, c2, 3 shouldn't be 0 all of them. Like if all like we cannot pick 0 for all of them, okay, except that we have to, let's mention here, not all 0, and then let's create a general condition, c1y plus c1y1 plus c2y2 plus c3y3 should be equal to 0 in order to be linearly dependent. Okay, now let's go ahead and create some equation. Here what I'm going to do is I'm going to compare the coefficients. So first, if you look at this one, c1 2t, so let's write that one here. Let's write t, let's take the t common and multiply the constant, so 2c1, and here we have plus c2 and plus 4c3 times t, and then we have constants. So let's go ahead and plug the constants. First we have c1 times negative 1, that's negative c1, and then c2 times 5, that's 5c2, and then c3 times negative 7, negative 7 c3, all of them should be equal to 0. Okay, and here you can see like in order to be 0, this one has to be 0 because we are adding these two together. So this term, this whole thing has to be 0, and also this whole thing has to be 0 in order to be altogether 0. So first let's pick up this one, this 2c1 plus c2 plus c3 times t is equal to 0. We can simply write this is equal to 0 because if you bring this, even if you put t and bring this t to the other side, it's still gonna be 0. So it's better to write this way so we can simplify and find out these c1, c2, c3 values. Okay, and then we put the next function, that is negative c1 plus 5c2 negative 7c3 is equal to 0. There are many different methods you can use to solve this one. Elimination is one of the best. You can choose any number, like you have to get rid of this one of them. So here it's easy to get rid of this c1. If you multiply this one by 2, this is going to become, the top one remains the same, that's 2c1 plus c2 plus c3 is equal to 0, and the bottom one is going to be negative 2c1 because if we multiply this one by 2, this is going to become negative 2c1 plus 5 times 2, that's 10c2, 7 times 2, that's 14, so negative 14 c3 is equal to 0, and if we add them together, this is going to become 0, and here this is going to be 11 c2, and then the third one is going to be minus let's see whether did I make any mistake. Okay, here we have 2c1 c3 is equal to 0, 2c1 c2 5c2, okay, c1, okay, this one should be 4, this one here, because it's 4tc3, so it's 4c3, so this one should be 4 right here. When we add these two together, this is going to become 10. Okay, 10c3, that is equal to 0. So here we are getting 11c2, and if I move this 10c3 to other side, that's going to be just 10c3. Then if we solve for c2 is going to become 10 over 11 c3. Now the next thing is we have to choose a C3 value. You can choose any value. The best thing is you can choose a value that can cancel this denominator. So if you choose 11 for this, that will be better. So I choose C3 to be 11. You can choose anything you want. If you choose 11, this is going to be 10 over 11 times 11. In that way we will get 10. So C3 is 11 and then C2 is 10. Now we have to find out C1. To find out C1, we can plug it in the first equation, and this one should be again 4C3. Okay, now let's go ahead and plug it in the first equation. 2C1, instead of C2 we put 10 because we found out C2 is equal to 10. So 5 times I'm looking at this equation, so this is not 5 times, this is just 10 right here, and then the third term multiplied by 4 times C3. We chose 11, so let's put 11 right here, and that's going to be equal to 0. And 2C1 is going to be 44 plus 10, that's going to be 54, and if we bring to the other side, that's going to be negative 54. Therefore C1 is going to be equal to negative 27. So these are the three constants. These are the three constants that is making this equation 0. So since we are getting constant multiplication, and when we add the constant multiplication it's becoming 0, it means this is linearly dependent. Now to show this one, to be 100% clear, let's put everything, this C1, C2, C3 in this equation and see whether we get 0. C1 is what? C1 is negative 27. Negative 27 times 2t minus 1 plus C2 is 10. 10 multiplied by t plus 5, and then C3 is 11 multiplied by 4t minus 7. All of this has to give us 0. Okay, now let's get rid of all these things. Okay, let's get rid of these things and then continue right here. Okay, if I multiply negative 27 by 2, that's going to be negative 54t. Negative 27 times negative 1, that's going to be plus 27 plus 10t plus 50 plus 44t minus 77 should be equal to 0. Now let's cancel everything we can cancel. Here you can see we have minus 54t, 44t, 10t, plus 54, minus 54. So all of these t terms cancels. And here you can see this is 27 plus 50, 77, minus 77. All of these constant cancels and we are getting 0 is equal to 0. Therefore this is linearly dependent. Now whenever you try to show this linearly dependent, you shouldn't use Wronskian. If it's linearly independent, if it is show linearly independent, then you can choose Wronskian. If you want to show linearly dependent, it's always, this is the best method to do that. Okay, and also I will explain why you cannot use Wronskian for this in the next video. I hope you guys find this video helpful, and thanks for watching. And if you're trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.